Hey, this is Vaughn Vernon. Thanks for joining me today, and welcome to my Design Accelerator tutorials. It's brought to you by my company Kalele. We're found at kalele.io, and you can look into my workshops, including my most popular workshop, the IDDD workshop, at kalele.io/IDDD workshop. Today I'm going to talk about commands, not queries. Is it really so that queries should never be used? Of course not. But there are times when commands are far more useful than queries. Let's look into this today and see why. Before we get into the main tutorial, I really need to clear up one last thing about why I hate the Outbox pattern, even revisited. So my previous tutorial explained further what position that I took on the Outbox pattern and why subscriptions using the approach that I referred to can work better. First of all, a question was asked following this. So what is a subscription after all? Well, as I said, a subscription is published to a messaging mechanism. It could be AWS, SQS, Google PubSub, Azure Message Bus, RabbitMQ, Kafka, whatever. Take your choice as to the messaging mechanism. But on the messaging mechanism itself, there must be some kind of a queue or topic or exchange or something like that in order to receive the messages. So a subscription is just a topic or exchange that is provided by a broker or a bus. And you see here we have Azure Message Bus represented. There's a topic, arrivals. We have RabbitMQ represented. We have a topic, departures. Up here we have AWS SQS. We have a topic, pricing. Here we have reviews represented as a topic through Google PubSub. Oh, and last but not least, Kafka. And we have a Kafka topic known as scheduling. All of these could be published to completely different messaging mechanisms with completely different topics or exchanges. In fact, actually here the RabbitMQ reference would be to an exchange. Let me just fix that briefly. Now, it's not like you have to support all of these at one point, at one time. It could be that you only support one messaging mechanism in your entire enterprise or open that up to external clients, whatever it happens to be. It really doesn't matter. The point is that each subscription is really just a topic or exchange that is provided on a message bus or broker. Another question was, how does a service subscribe to this? It depends on the scope of the service, the maturity of the service, the team, and the security involved. Perhaps there's even some kind of financial stake, such as subscriptions, actual paid subscriptions to this, which would then encourage the team to create a self-service API or UI to subscribe to this. On the other hand, if it's internal only, it could be that there's just simply communication between one team and the publishing team who needs to have a subscription to it. All of these things are very common, and there's a range to how the communication between teams could be done. It could be through email. It could be some kind of defect tracker or request mechanism for features, or it could just simply be, sort of like talking over the cubicle or across the desk to someone on the other team. So this is really versatile. You should use it to the best possible situation for your circumstances. One last point that I'll make about this entire topic is to be careful of cost. For example, be sure to consider the cost of Kafka in the cloud. If you look into this, you'll likely find that long-term storage for a Kafka topic, as in forever retention, depending on the number of messages that will be persisted over the long term, can be very costly. Of course, you may come to the same conclusion for any kind of cloud solution, so just be careful about this. Don't assume that the costs are cheap just because you're talking about disk storage, because under certain circumstances, you're going to be charged a lot of money for a certain kind of storage or using a mechanism in the cloud. So check into that. Don't assume that any given organization will just pay that price. And I would say even especially for startups, the cost of Kafka or any long-term storage solution could be untenable for a given startup. And plenty of startups have failed because of surprise invoices from a cloud provider. So just be cautious about that. I'm not trying to make any kind of very specific prediction. Perhaps you have more or less messages to be stored in a Kafka topic or less replication or anything like that. But whatever you do, just don't assume that a business, an organization, will just be fine with whatever kind of storage you consider to be reasonable for them. That's always a business decision. Make sure that they are aware. I don't know about you, but I'm done with this topic. So I'm going to move on now. Hopefully I've provided enough information. No doubt others will still have questions about this, but I'm not going to readdress this. I'm ready to move on with commands, not queries, the main topic for this week. Before we get started into the depth of this topic, I just want to first say, as a disclaimer, or boilerplate, or whatever it might be, I am not trying to tell you that you should never use a query. Obviously, you should use a query. Queries are useful when, for example, you need to display data on the user interface. You need to get information from the application, the service, whatever it happens to be, and that information, the data, needs to be rendered onto the glass of a UI for a user to use. Another hopefully obvious reason to use a query is for reporting. Business intelligence, machine learning results, anything like that for helping a business to make decisions. Of course, you're going to need to perform queries and use the queried information to render it in various formats. This could possibly be displayed in a user interface or a printout. Hopefully we're not burning too much paper these days, but the point is this represents a different kind of user interface, which is a report. So these are two obvious reasons to use queries. The problems with queries occur when, for example, one object queries another object, it gets information, some data back from this object B, and then object A does some sort of compute here, decision making, whatever the business logic says that it should do, and then it sets data back on object B, as you can see here. And it's likely multiple sets because multiple properties or attributes on object B need to change. This is a problem. Why? There are at least 4 reasons, which I key on now. First of all, the data on B belongs to B. It doesn't belong to A, and whenever A takes that data and makes a decision on it, it's making a decision on something that doesn't belong to it. The second reason is the tight coupling of A to B. This happens both when getting data and setting data, and depending on the shape of B and what A has to navigate in B in order to reach the information that it needs to make a decision, well, the coupling even gets worse. So that if the shape of B changes, then that's going to ripple back to A. Besides the fact that there is just that general coupling and it has knowledge of B that it really shouldn't have. As a reminder, I talked about coupling, both good coupling and bad coupling, in my November 18th, 2024 Design Accelerator tutorial. All coupling is not bad. You have to have coupling in order to do anything, to accomplish anything with software. On the other hand, there is bad coupling, and this is an example of bad coupling. So look at that episode and you'll learn more about the topic. The third problem is that existing knowledge is disclosed. That is, knowledge within object B, its data, is disclosed to object A. This is not good. And any knowledge that is gained within the computations of object A are again lost because the information is set back on object B. The data that contains knowledge is set back on object B. So we have leaked knowledge in a lot of different places here. If you want to know more about not disclosing information, look into Demeter's law, or the law of Demeter. The law of Demeter indicates the importance of not disclosing knowledge. It is the law of least knowledge between objects in computing. And I just want to clarify something too, that when I said that the information being set back on object B is a loss of knowledge, it doesn't mean that the data is lost, but the reason why that data was changed and set onto B is lost. Because B is now just a data container, it doesn't have any traceability of why that knowledge was gained, which is actually now within object A. So the whole way in which this information is being both disclosed and calculated or processed is just completely backwards. The fourth problem is really very closely related to what I was just discussing, and that is that the opportunity for new knowledge is lost. So there's actually an opportunity for new knowledge to be captured. Not only the data, the information that is the result of some calculation or processing, but the fact that we're losing the reason why the data was changed, modified in some way, is completely lost. Now, this is shown on a relatively micro scale at this point because we're just talking about two objects, but I think it will become clearer when I move on to the next point, which is service to service knowledge loss. Here we have 4 different services. The main idea here is that a customer can book some kind of appointment, and the appointment is for a service. The services are provided by some kind of skilled individuals who have profiles that declare their skills, and there's scheduling, which tracks the skilled individuals' open schedules or what's already booked, and so the customer needs to have an appointment made with one of these skilled individuals for a service on a specific date and time. In order to fulfill this, imagine that we decide just to query the services, and we find out for the customer what service is available, and they're going to select a specific service, so we query that service for them. We also then query for the skilled individuals who have the skills that are needed for this kind of service to be fulfilled for the customer, and then we query for the open date and time for these skilled individuals to see if they have an open schedule for the customer to set an appointment with them. Okay, so we gather this information and we have it here. Everything seems to be great. Let's book the appointment. Do you notice a problem with this? What if anything goes wrong here? What if the service that they're looking for is available, but let's say that the skilled individuals are not available? What if the location in which this customer needs the service does not have those skilled individuals? Or let's say the schedule for any of these individuals who have skills is not open at this time for the customer. Let's even say that the customer is willing to pay a specific price point, but the price for the service for the skilled individuals in their area is not compatible with the price that they're willing to pay. There are just all kinds of situations here that could occur that when you query for the information from these, what if it's not available? Or what if it's available in limited quantity? Or what if it's unavailable for the time frame that the customer wants? What happens in all of these situations? All of the calculations or processing that must take place are all happening back here at the appointment service. That means any of the unavailability or incompatible pricing, skill level, or scheduling is all being determined right here in the appointments. What kind of limitations does that pose? The problem is all of the knowledge is now in appointments. The knowledge of the situation that presents itself is all right here. So if we want to then transfer that new knowledge to the services or to the profiles or to the scheduling, we have to set data back on those. It means that we have way too much knowledge of the services, profiles, and scheduling. We shouldn't have any of that knowledge. We should only know about appointments right here. So calling back on the services in order to set data, in essence, to say, this is your new situation, do something about it. For example, what if we had to recruit more skilled individuals for a given location? What if we had to recruit because of the scheduling? Perhaps we had these skilled individuals, but they were scheduled on that time. Also, what if we don't want to recruit more individuals because the ratio between the skilled workers that we have and the number of appointments that are set in that area means that we are working at capacity, which is good, or just below capacity. Because when we book an appointment, we aren't going to say we're near the threshold of service availability for profile scheduling, whatever it happens to be. If we did, we would query again onto each of these services to find out the situation, and then we would have to set back on. It's just completely upside down, the same way that the previous example of two objects, object A and B, were upside down. Note the contrast now between query and set and executing a command. If a command such as confirm service request is executed against the services and designate skilled workers is executed against profiles and resolve availability is executed against scheduling, it's very clear that the responsibility for performing the operation based on the data that the service owns is the responsibility of that service. In this case, the service is named services. In this case, the service is named profiles. In this case, the service is named scheduling. The point is that now when the command is executed within the proper location, the owner of the data has full control of the knowledge. It maintains the knowledge that belongs to it specifically. So now the knowledge is properly distributed across the different services with a specific responsibility. But now you're probably thinking, okay, so the services own their own knowledge, but how does appointments find out about the result? And how does other decision making occur? I thought you might ask those questions. When confirmed service request is executed on the services, it can emit either service request confirmed or service request rejected. When profiles receives and executes the designate skilled workers, it can emit either skilled workers designated or skilled workers not designated. Similarly, when scheduling receives and executes resolve availability, it can emit availability resolved or availability unresolved. In any of these cases, whether it's confirmed or rejected, additional information besides just what is absolutely necessary to show that the service request was confirmed or rejected could provide additional information. For example, even if scheduling availability is resolved for a given set of skilled workers, you still might decide to include the range of availability. For example, if there's a total of 10 such skilled workers in a given area, you might want to say that the availability is resolved, but there are only 8 out of 10 individuals remaining. Or if it's unresolved, there are 0 out of 10 remaining. Each of these can convey different kinds of situations to the rest of the entire system. So appointments will not only react to the availability or unavailability, but for example, services might surge pricing. Or profiles might indicate that they need additional skilled workers. Perhaps we're even going to introduce a new recruiting service that's going to send out offers to individuals to join the service by submitting profiles. So all of these situations that could occur open up various opportunities for the services that are providing each of these responsibilities that they can react in certain ways given the current circumstances. The information carried by each of these events should be designed according to consumer-driven contract. That is, the consumers of the events should have input into what the events carry, the information that they must deliver along with the notification. These two approaches that I've been discussing, that is querying, making a decision, and then setting data back on a capability, could be known as ask, decide, set. This is versus where a command is used to tell a capability what to do on your behalf, which is known as tell, don't ask. This is known among object practitioners who go back several decades. It comes from a developer named Alex Sharp, and Alex Sharp wrote a book called Small Talk by Example. And in that, he discussed tell, don't ask. You can actually download that book for free on the internet, and you'll find a lot of good guidance on object-oriented programming in general, based on one of the original object-oriented programming languages, Smalltalk, which is the language that was first known as object-oriented. Although you would say that Simula was the actual first object-oriented programming languages, except that it wasn't known as object-oriented at the time. It simply provided the features of object-oriented programming that Alan Kay later named object-oriented programming and associated that with the Smalltalk programming language. I hope that doesn't confuse you too much. But anyway, that's some history of object-oriented programming. I've kind of spent all the time that I have today on this topic. There is more to discuss about this. You might be wondering, well, what if the events don't carry enough information? How would I get more information, for example, in appointments from the service's capability? How would you do that? Well, it opens up some other interesting questions. I'll hopefully look into that another time. Thank you for joining me today again. This is brought to you by my company Kalele. You can find us on the web at kalele.io, and my most popular workshop, which I will be teaching toward the end of January 2025, is found at kalele.io/IDDD workshop. I am going to be teaching the next version of the Implementing Domain-Driven Design workshop, which actually takes a very project-based approach, and we're going to discover all the way from the initial specifications for a whole system, as well as strategic design from bounded context and context mapping, all the way through tactical modeling, and we will actually create multiple bounded contexts in this workshop. I hope you can join me there. I look forward to meeting you if possible. Until the next tutorial, take care.